Hello. Hello everyone, very good afternoon. Kindly confirm if audio video is clear. Very good afternoon everybody. Please confirm if audio video is clear so that we can start the session. Hello. Just one. Hello. Okay, all fine. Thank you very much. So let's begin the session. So once again, very good evening to all of you. And from this particular session, we are going to start the YouTube series for discrete mathematics. Now, in discrete mathematics, the very first chapter that I am going to discuss will be set theory and algebra. So there are various parts which are included in the set theory and algebra. What are they? So the very first thing will be sets and relation. We will talk about concept of sets, and we'll see that how relations can be defined on the on two different sets or on the same set. So we'll talk about sets and relation. We will talk about functions, and we'll talk about group theory. So this will be the three things which we will discuss in set theory and algebra. So in this particular series, I'm going to cover all the topics of set theory and algebra, and then we'll have another session of discrete mathematics for other topics of discrete mathematics. So let us first cover these three things. So this is the very first lecture on the set theory and algebra. What am I going to discuss in this session? So I'll introduce the concept of set. So this will be a very basic session. Please try to understand. It's not so that all the things in the GATE exam are difficult. No. So there are some easy things. There are some tough concepts. There are some easy concepts. But those easy concepts can be combined with the tough concepts to formulate a good quality question. So please try to understand. You should have a very strong basics. So, and the basics are defined based on the simple concept. The accumulation of simple concept will eventually make you capable of solving the good quality questions. So please, so we'll introduce the concept of set. That will be a very basic thing. If you are good in the mathematics, then I believe that most of you already know most of this concept. But I'll just give you a quick revision in today's session, and from tomorrow onwards, we'll eventually have more gate oriented questions from this particular chapter. Okay. Now we'll have the representation of set, that what are the ways in which the sets can be represented and different types of sets. So these are all the basics. We'll see them one by one. So what is a set? So the very first thing is, sir, what do I mean by a set? So what is a set? Any collection? No. First of all, it should be a collection of distinct element. In a set, the element cannot be repeated. Apart from that, the ordering in which the element appears within the set is not important. So a well-defined unordered collection of distinct elements. So all these terms are important. Well-defined means you should know that what are the elements or what are the members of your set, and unordered, ordering will not be important. The elements must be distinct. So let's take an example. If I say A equals to 1, 2, 3, let's take 4 also. So these are the 4 distinct elements. Let's try to understand that what if we change the order of this element. So if I say 4, then I write 3, then I write 1 and 2. Will there be any difference? No, sir. These two are exactly same. These two are exactly same. There is no distinction based on the ordering of the element within the set. Apart from that, some of you may say that set is a collection of similar type of elements. No, this will be a wrong definition. So it is not necessary. You may have some alphabets, you may have some integers, whatever you want may be present in your set, but the idea is that what are the members of the set must be well defined. That okay, there's one character A, there's another character B. There are two integers 1 and 2. Similarly, if I try to define, then I can have 1, 2, I can have A, B, I can have a something like January, February, whatever you want to include within the set, it's perfectly fine. There is no restriction that what type of element should appear in a set. So anything can be part of a set, but the only thing is they must be well defined, that what is being defined by those particular elements of the set. Ordering is not important, and another thing is they should all be distinct. There cannot be any repetition. So let's try to understand. If I just give you an example. Is it a set? No, sir, it is not a set. Not a set. So what will happen? So the set with respect to this collection of element, the idea is that no element should appear twice, because the element 2 appeared 2 times, therefore it is not a set. Basic definition is clear, that what do I mean by the set. So that's the very basic term. Now please try to understand another definition related to set theory. One that is the number of elements in a set. So that is what we define as cardinality. But before that, let's try to understand that what are the different ways in which these sets can be represented. Generally, you have seen these sets in this particular format, but there are other ways of representing the set. Hello, Devil. Hello, Ajit. So, what are they? So, there are 3 different ways in which these sets can be represented. First one is roster form or tabular form. So, what do we do in this particular form? Please, I'm not going to define the exact definition because it's not going to be asked. So, what happens in the roster form or tabular form? So, in the roster form or tabular form, we will list all the elements of the set within the curly braces. So, whatever the elements of these sets are, they will be listed within the curly braces. So, let's try to understand if I write something like this. So, this is the roster form or tabular form. Another is the set builder form. What will happen in the set builder form? The same set may also be represented in the set builder form, and it may not be represented in the set builder form. So, why these different notations are required? I'll explain it in a while, that why different notations are required. Okay. So, but let us first try to understand that what do I mean by roster form? What do I mean by set builder form? So, please try to understand. If you look at this particular set, what are the members of this set? So, it is a set containing 4 integers 1, 2, 3, 4. Do you realize that these numbers are the natural numbers, and all these natural numbers are less than 5 or less than or equals to 4. So I can also define this set, same set A, as what? So set A is nothing but a set of element X such that, how do you define the definition of set? So A is nothing but a set of element X such that X is less than or equals to 4 and X belongs to natural number. So rather than listing all the elements, rather than listing all the elements of the set, we can give the definition that what type of element will eventually become the part of this particular set. So this property will eventually define the elements of the set. So this property will be used to build the set. Clear? So there may be another definitions. Just try to understand that if I write another set B as that is nothing but a set such that X belongs to real number, that I am considering a set of real number, and I am saying that X will be greater than equals to 0 and X will be less than equals to 1. So please tell me, how many real numbers will be there between 0 and 1? So there will be infinite real numbers between 0 and 1. So the idea is, please look at this carefully. That sir, why different notations are required? Why different notations are required? I can list these elements 1, 2, 3, 4 individually, and this set A, which is containing 4 elements 1, 2, 3, 4, can be represented in the roster form or tabular form. But if I try to represent all these real numbers, if I try to represent all these real numbers in the roster form, will it be possible? Can I list all infinite real numbers between 0 and 1 in a set? No sir, it will not be possible. So getting the idea that sometime it may not be possible to represent a set in the roster form, but it may be possible to represent that set in the set builder form. Similarly, if I give you an example, that let's take a set C in which there is no 0 0.2, 0 0.5, 0 0.6, 0 0.9, 0.925, so etc. Let's assume these are the elements of your set C. Now the problem is, there is no property, if there is no property which can be justified to build these elements based on certain definition, then I cannot represent this set C in the set builder notation. Getting the idea? So set B cannot be represented in the roster form, set C cannot be represented in the set builder form. Therefore, different notations are required, but this one is a statement form. It's a simple notation. So it's nothing but, if I simply want to write A, then what is set A? Set of all natural numbers less than 5, or you can also say less than or equals to 4. That's absolutely fine, but it's just a notation. Yeah, you can simply represent the definition, or you can simply represent the elements in the form of a statement that what will eventually become the elements of your set. Similarly, if I let's assume it's set of all natural numbers. Up to you that how do you want to represent in the form of statement. So generally, please try to understand that why these different notations are used. So set builder form can be used to define the finite set as well as infinite set. Roster form will be generally used to represent the finite sets. What do I mean by finite sets? Finite sets are the sets in which the number of elements are finite, and you will be able to list all those elements within the curly braces. Clear? So that's the simple notation. Now let's try to understand the cardinality of a set. What do I mean by the cardinality? Cardinality is nothing but the size of the set or the number of elements in the set. Clear? So what? Sir, cardinality of a set refers to the total number of elements, present in a set. Okay. Now, it is also known as size of the set. Sir, how do we denote this? If you have a set A, then the cardinality of set A will be denoted by mod A. Cardinality of set A will be denoted by mod A. So it's simple. So let's assume if I have A equals to 1, 2, 3, A, B. So what is the cardinality? How many elements are there in this set? So there are 5 elements. 1, 2, 3, 4, 5. Please now, so what will be cardinality of B? Please try to understand. B is not a set. So there is no point of defining the cardinality for something which is not a set. So don't say that, sir, some people may say you that this set is actually 1, 3, 4. The equivalent set may be 1, 2, 3, 4. The set which is corresponding to this collection of elements may be 1, 2, 3, 4. But in the given format, it is not a set. In the given format, it is not a set. So we will not define the cardinality for this collection of elements with respect to whatever is being represented by this B. Clear? So because it is not a set. But anyway, this is a simple definition that cardinality of a set will be nothing but the number of elements in the collection or the number of elements within the set. Simple definition. I don't want to make things complicated. If you guys have any doubt, please let me know. Okay. Now let's try to define the types of sets so that we will be able to discuss more about this cardinality aspect. Now, the very general statement you must understand is that cardinality is defined for a finite set. That is only when the number of elements are finite. If the set is an infinite set, let's assume if I take the set as a set of all natural numbers, then how many elements are there? So the number of elements in the set of all natural number will be infinite. So how do we define the cardinality for a set which contains infinite number of elements? How do we define the cardinality for this set B? That is the set of all real numbers between 0 and 1, including 0 and 1. They will also be infinite real numbers. So we don't know the actual the numbers in this set are not finite, therefore we cannot define the cardinality. We cannot say that the cardinality is infinite because infinite is not defined. Infinite is not defined. So can I generally say that cardinality is defined only for finite set? Cardinality is defined I'll give you the definition of finite sets, infinite sets, all other types of sets when we move to the types of sets. Anyway, so I hope the definition of set is clear to everybody. Definition of set is clear to everybody. Representation of set is clear to everybody. And you have all understood the concept of cardinality, that cardinality or size of a set is nothing but the number of elements in that set. Now, if we move forward and try to understand the different types of sets, so what will be the different types of sets? Empty set is one set which contains no element. So let me just give the names first, then I'll define them one by one. So empty set, that will be a set which contains no element. Singleton set will be a set in which there is exactly one element within the set. Now finite set, a set which contains finite number of elements. Infinite set, a set in which there are infinite number of elements. Equal set, when all the elements of two sets are exactly same, then those two sets are said to be equal. What do I mean by equivalent set? If the cardinality of two sets A and B are same, then we say that A and B are equivalent. Similarly, universal set. So let's try to understand that if you take a collection of all the students of a university, then you define the students of computer science branch, you define the students of electronic branch, you define the students of IT branch, you define the student of DA branch. And if you ultimately take the unions of all those students of CS branch, EC branch, IT branch, DA branch, then you will eventually get the students, then you will eventually get the set of all the students in that university. So universal set is basically nothing but it is a union of all the subsets related to the problem. So, I mean, if we are eventually discussing something related to the students of a university, then ultimately the universal set in that scenario will be the set of all the students of that university. At a particular time, you may not be interested in all the students of that university, but that set of all the students of university will eventually form the universal set. Apart from that, we'll define the concept of subset and superset. We'll try to understand the definition of proper subset. We'll try to understand the definition of power set. These are important. These three aspects will be important. These are just good to know information. But anyway, we'll discuss all of them one by one. So what do I mean by empty set? Sir, empty set is nothing but a set with no element in it. So empty set is a set with no items or elements in it. It is also known as null set, or it is denoted using, how do we denote this? So empty set is denoted using phi or, so basically these two are equal. What sir phi is exactly is this? So you eventually understand the meaning of this. What is this? There are set. This is actually a set. Do we have any element in this set? So sir, it is a set with no elements in it. So this is the notation for empty set. You will eventually be more comfortable with this when it is about understanding the equation, but the notation to represent the empty set or null set will be phi. These two are exactly same. If phi is written, then it eventually represents a set without any element, or if given thing is a set without any element, then this will be same as phi. Okay. Now my question is, sir, what will be the cardinality of set phi, or cardinality of set phi, or the cardinality of an empty set will eventually be 0, because how many elements are there in this set? How many elements are there in this empty set? Sir, there are 0 elements in the empty set, therefore cardinality of empty set will be 0. Sir, please tell me, empty set is a finite set or not? So 0 is a finite number. Can we confidently say that there are 0 elements in this set? Yes, sir, we can confidently say that there are 0 elements in this set. Therefore, empty set is a finite set. Please try to understand. Empty set is a finite set. Generally, people will ask that we are getting confused whether empty set is a finite set or not. Yes, empty set is a finite set because the number of elements in that particular set are finite. 0 is a finite number. 0 is a finite number. Therefore, you don't need to worry about it. Okay, sir. This is it. So these are the basic definitions about empty set. We'll discuss more about the empty set as we move further in the same session. But this is the general understanding. But at that empty set is nothing but a set with no elements in it, will be denoted using phi or empty curly braces, and the cardinality of the empty set will be considered as. Okay. Okay, let's move to the next thing, that is singleton set. So it's very easy. So what is a singleton set? Just like empty set is a set with no elements in it, similarly singleton set is a set with exactly one element, or it is a set with single element in it. So singleton set is a set that has only one element. Whatever, like, up to you. So for the cardinality of singleton set, if you have any singleton set, the cardinality of that cell will always be 1. Nobody is going to ask this. Nobody is going to ask. Please don't worry. So, what do I mean by finite set? Finite set are the set having finite number of elements. If any set has finite number of elements, it will be finite set. Okay. Very fine. That A is a set of all natural numbers. Then what will be? Let's use a different notation so that we don't get confused. So, what will be cardinality of D? The cardinality of D is not defined. You don't know the number. You don't know the number. Now, if the cardinality cannot be defined, then so basically tell me, if we know the finite set, what will be an infinite set? Finite set will be a set which will have finite number of elements. Finite set will be a set which will have finite number of elements. Then what will be an infinite set? Sir, infinite set is nothing but a set which is not a finite set. A set which is not a finite set will be an infinite set. So an infinite set is a set that is not finite. Infinite set is a set that is not finite. That means if the number of elements are not finite, then it will become an infinite set. Now, why do we define the definition like this? So please try to understand. Infinite sets may be countable or uncountable. Finite sets are always countable. Finite sets are always countable. If you want to write down, down, you can note down that finite sets are always countable. You can always count the numbers in the finite set. Finite sets are always countable. What do I mean by countable sets? That is, we can actually count the number of elements in those sets. But when we talk about infinite set, infinite sets may be countable or may be uncountable. This is a tricky definition which is related to concept of equivalence of two sets, or more generally, it is actually defined on the definition of bijective function. When do we say that two sets have same cardinality or equivalent? So they must have, basically the idea is that two sets are said to be equivalent if there exists a bijective function between those two sets. In the similar manner, we define the countable set as, what is our countable set? So countable set is nothing but if there exists, for an infinite set, if there exists an one and onto function between set of natural number and the given set, then that particular set will be countable set. What's the reason? Sir, all subjects will be coming, or yes, ultimately all the subjects will come, but one by one. You just need to understand that we cannot start all the subjects at once. Therefore, we will keep coming with subjects one by one on this particular channel. So don't worry that we will cover all the topics, but not necessarily at once. By the end of October, November, we will ultimately cover all these subjects along with all the topics. So that's the idea. Please. This is a very tricky definition. Infinite set may be countable or uncountable. The definition of countable set and uncountable set itself will take 2 to 3 hours. The definition of countable sets and uncountable sets itself will take 2 to 3 hours. Apart from that, first of all, I'll have to explain the concept of one and onto functions. If you do not understand the concept of one and onto function, it will be very difficult to understand the countable set and uncountable set. But I can give you a small intuition that when do I say that the infinite set is countable? If we can start the counting of the elements, of the set, then that particular set is called countable set. Please try to understand. If we can start listing the elements of the set, then it will become countable set. If we cannot list the elements of the set, then it will be called uncountable set. Please try to understand. So, set of all natural numbers is a countable. What type of countable? Infinite set. Why? Can you start listing or can you start counting the elements of the set of natural numbers? Sir, please try to understand. I'll say, okay, 1, then write 2, then the third element will be 3, 4. This is another thing that this listing may never end. This is another thing that this listing or this counting may never terminate. But you are able to count the elements in this set if you are able to list all the elements of the set, or if you are able to count, if you are able to start the counting for the elements of the set, then it will be called countable set. Yeah. But let's take another definition. Set of all real numbers or whatever, set of all real numbers is an uncountable finite set. Now the question is, let's, even if I write set of all positive or non-negative, so that I can give you the set of all non-negative. All real number will also be uncountable, but please try to understand this. Set of all non-negative real numbers is an uncountable set. Please look at this. The first non-negative real number will be 0. The first non-negative real number will be 0. Okay. But please tell me, what will be the next real number after 0? Can you list the next real number after 0 in this set? No, sir. We will not be able to list the next real number after 0. It may be anything. You can keep writing 0.000000000000001. If this is your next number, then the another real number which is between 0 and 0.00000000001 will be infinite, because the number of real numbers between two numbers will always be infinite. Okay? So you cannot list the next number after 0. That is, you cannot start counting the number of this particular set. Therefore, this set is an uncountable set. It is the basic understanding of countable set and uncountable set. Clear? But anyway, if a basic definition of an infinite set will be what? Sir, a set which is not a finite set. A set which is not a finite set will be an infinite set. You should only know that infinite set may be countable, may not be countable. Some of the infinite sets are countable sets and some of the infinite sets are uncountable sets. That's the only thing which does it. Now, what do I mean by equal set? When do I say that two sets are equal? Now, let's look at this. If I define set A as 1, 2, 3, if I define set B as 3, 1, 2, they may not look exactly same, but what do I mean by equal set? So let A and B are two sets. A and B are said to be equal. When do I say that sets are equal? When every element set of set A is included in set B and every element of set B is included in set A, then we say that A is equals to B. So let A and B are two sets, then A and B are said to be equal set if and only if every element of set A is included in B. So first check this particular property, whether every element of set A is included in B or not. So this element 1 is included in B or not? Yes, sir. Element 2 is included in set B or not? Yes, sir. Element 3 is included in set B or not? Yes, sir. So every element of set A is included in B, but it's not sufficient. And every element of set B is included in set A. So let's check. 3 is included in A or not? Yes. 1 is included in set A or not? Yes. 2 is included in set A or not? Yes. So can I say that A is equals to B? A is equals to B. Yes. Another example. So that's 1. Now, if only one contain another, so if I say 1, 2, 3 and B is 3, 1. So, please check whether A is contained in B or not. That is, all the elements of set A are included in B or not. No, sir. 1 is included in B, but 2 is not included in B. Two is not included in B, therefore A is not equals to. Here, all the elements of A are included in B, all the elements of B are included in A, therefore they are equal. But otherwise, if any of the element of a particular set is not included in another set, then those two are not equal. Please remember what? If two sets A and B are equal, then their cardinality will also be same. Yes or no? If A equals to B, then cardinality of set A will be equals to cardinality of set B. Sir, why it is so important? I'll explain in the next definition. Sir, what do I mean by equivalent set? We have understood the concept of equal set. For equal set, or if there are two sets, then all the elements of both these sets should be exactly same. But what is the definition of equivalent set? two sets are said to be equivalent if their cardinality is the same. Two sets are said to be equivalent if and only if they have same cardinality. If the cardinalities of the sets are same, then they will be equivalent. They need not have same element. Please look at this. So if I say A is equals to 1, 2, 3, if I say B is equals to 1, A, B. Now, what is cardinality of set A? Sir, cardinality of set A is B and cardinality of set B is also 3. Mod A equals to mod B. Therefore, A is equivalent to B. It is sufficient. Getting the idea? So, for equivalence, the elements need not be same. For equivalence, the elements need not be same. Only the cardinality should be same. Clear? Okay. So, come on. What happened? So, do you realize that in this particular case, mod A equals to mod B, therefore A is equivalent to B. But do we have all the elements of set A in set B? No, sir. So, if any of the element is missing in the another set, then they cannot be equal. But A is not equals to B. But A is not equals to B. What does it mean? The sets may be equivalent even if they are not equal. Sets may be equivalent even if they are not equal. But if these sets are equal, then they are guaranteed to be equivalent. If these sets are equal, then they are guaranteed to be equivalent. So, mod A if A equals to B, then it is necessary that mod A equals to mod B. Therefore, A and B are equivalent as well. So, if sets are equal, they will be equivalent. If these sets are equivalent, they may be equal, they may not be equal. But if sets are not equivalent, they can never be equal. If the sets are not equivalent, the cardinality of the set itself is not same, then how come the elements will be exactly same? Not possible. Clear? So, let's assume A is nothing but 1, 2, 3. B is 1, 2. Now, mod A equals to 3. Mod B equals to 2. Mod A not equals to mod B. Mod A is not equals to mod B. Therefore, A and B are not equivalent. Please, if the elements are not equivalent, they cannot be equal. And hence, A and B are not equal as well. I would rather say A and B cannot be equal. Clear? Okay, let's move to the next definition, that is universal set. As I told you, this will be a very basic definition. We will not talk too much about this particular thing, but I'll just explain what do I mean by universal set. So, the universal set is the set that contains, all the elements of other related sets with respect to a given problem under consideration. So, let's assume, how do we denote the universal set? Generally, the universal set will be denoted using this uppercase letter U. So, let's assume that, don't take this particular format. I'll explain the Venn diagram in the next class. Then I'll start discussing in this particular format. But let's assume that if I have set A as 1, 2, 3, 7, 9, set B as 3, 2, 5, 6, 8, set C 1, 5, 8, 9, 10. These are some sets. Now, if there is any set, U, if there is a universal set U which contains the elements of all these sets, sir, 1, 2, 3, 4 is not there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This U may be universal set because all other sets are derived from the universal set. All other sets corresponding to the problem will be derived from the universal set. So that's a simple concept, as I told you in the very beginning. Let's assume that you have a set of all the students of a university, so it will eventually become the universal set. If you take the students of computer science branch from that particular university, then it will become one set from that universal set. If you take the students of all, if you take the set of all the students of ECE branch, then it will become another set from that particular universal set. If you combine all those students of the different branches, then you will eventually get your universal set. Clear? Next, this is very important. Subset and superset. So I did not write the definition because this is important. So let's look at this. Let A and B are two sets. How do you define subset? So for a set to be a subset of another set, what is necessary? That all the elements of that particular set, which is being called a subset, must be included in the another set. So just that A and B are two sets. A is called a subset of set B. A is called a subset of set B if all elements of set A, if all elements of set A are included in set B. If all the elements of set A are included in set B, then we say that A is a subset of B. How do we denote this? Denoted by A is a subset or equal. Please look at this carefully. So if I have a set B, let me first define B. That I have 1, 2, 3, 4, 5. Then I have a set 1, 3, 5. So please tell me, the only restriction is that all the elements of A must be included in set B. There is no such restriction that all the elements of B should be included in set A. So please check whether all elements of A are included in set B or not. 1 is included in set B, 3 is included in set B, 5 is included in set B. So that's one thing, that yes, A here, A is a subset of B. Now please check whether B is a subset of A or not. So if A and B are two sets, then A will be called subset of B if all the elements of set A are included in set B. So when exactly B will be called subset of A? When all the elements of B are included in set A. So please look at this. Sir, 1 is included in set A, but 2 is not included in set A. So can I say that A is a subset of B, but A is a subset of, come on, what is happening? Of B, but B is not a subset of A. A is not a subset of B, but sorry, A is a subset of B, but B is not subset of A. Okay, next example. A equals to 1, 2, 3. B equals to 2, 3. Now my question is A subset or equals to B? Thus, all the elements of set A are included in set B. Sir, 1 is not included in set B. Therefore, A is not a subset of B. Let's check for B is subset of A or not. Check whether B. Sir, 2 is included in A, 3 is included in A, but element 4 of set B is not included in A. Therefore, B is not a subset of A. It's also true. So you just need to understand, given two sets, it is not necessary that one will be subset of another. It is not necessary that one will be subset of another. So they may or may not be subset of one another. Let's look at the third one. Okay. A equals to 1, 2, 3 equals to. Now please check whether A is a subset or equals to B or not. Yes, sir. All the elements of A are present in B. Second, let's check whether B is a subset or equals to A or not. All the elements of B are present in set A. Now, there's an important learning. If you have two sets A and B, if A is subset of B and B is subset of A, then this is possible only when both these sets are equal. Clear? So, if A is a subset of B and B is a subset of A, if both of them are true, then it is guaranteed that A will be equals to. It is guaranteed that A will be equals to. Yeah. So these are some properties, sir. Another thing you must understand is that, sir, what do I mean? What do you mean by this concept of superset? What do you mean by this concept of superset? So if A is a subset of B, if A is a subset of B, then B will be called a superset of A. Then B will be called superset of A. Just note down, if A is a subset of set B, then B is called superset of set A. B is called superset of set A. So subset and superset definitions are not different. If A is a subset of B is known to you, then B is superset of A or not, it is also known to you. They are exactly same. A is subset of B, then B is superset of. Okay, there are some important properties which you must understand. What are the important properties related to subset and superset will be? Note. First, phi, which is the empty set. We just defined the empty set as phi. So phi is a subset of every set. Phi is a subset. Whichever set you have in your hand, or whichever set you are uh, trying to understand, one subset of that set will always be phi. Another, for any set A, for any set A, the set itself will always a subset for, or I would rather say, for any set A is a subset of set A itself. In layman language, if you want, every set is a subset of itself. Every set is a subset of itself. So phi will always be a subset of every set, and every set itself will also be a subset of itself. Right? So every set is a subset of itself. So let's try to understand in more detail. Look at this. Let A equals to 1, 2, 3. Now, if somebody asks you that what are the subsets of set A? What are the different subsets of set A? So first of all, sir, how do we create subset? So first subset will be, sir, one thing is guaranteed that phi will be subset of every set. Phi will be subset of every set. So that's one thing, that out of 3 elements, you may choose 0 element out of those 3 elements and you can create a subset. Apart from that, from this 3 elements, you can choose exactly one element and you can create a subset. So, sir, you can choose one out of these 3 elements, 1, 2 and 3, or you can choose 2 out of these 3 elements, 1, 2 and 3, or you can choose 3 out of these 3 elements, 1, 2 and 3. This will become 3 more subsets of set A. But this is the subset of size 0. How many elements in this subset of set A? Right, no element, that is 0. So these are the subsets of size 1. Okay. Similarly, out of this 3 elements, we can choose 2 elements and we can create a subset. So we can choose 2 elements, either 1, 2 or 1, 3 or 2, 3. These are the subsets of size 2. Finally, the set itself. Why, sir? So out of 3 elements, either you can choose 0 element, out of 3 elements, you can choose 1 element, out of 3 elements, you can choose 2 element, or out of 3 elements, you can choose all 3 elements. Out of 3 elements, you cannot choose 4 elements. Out of 3 elements, you cannot choose 4 elements. So this is basically the subset of size equals to. I'll come back to this particular slide to represent the concept of number of subsets of a given set. Yeah. So this is the basic understanding that if you are trying to determine the subsets of a given set, then you will first try to identify how many elements are there in set A. So out of those elements, let's assume if there are n elements, then out of n elements, you will create some subsets of size 0 by choosing 0 element out of those n element. You will create some subsets of size 1 by choosing 1 element out of those n element. You will create some subsets of size 2 by choosing 2 elements out of those n elements, and you can choose up to all n elements out of n elements. You cannot choose more than n elements out of n elements, and if you do so, you will be able to identify all the subsets of a given set, and then we'll write an equation. We'll try to sum it up and we'll try to understand that how many subsets of a given set are possible. Clear? Okay, so that's just the definition of subset. What do I mean by subset? Subset and superset are the same thing. If two sets are subset of one another, then they are guaranteed to be equal to each other. Otherwise, to check whether one set is subset of another or not, you just need to see A will be called subset of B if all the elements of set A are included in set B. All the elements of B need not be included in set A. If you are looking for A is a subset of B or not, then check whether elements of A are included in B or not. Next is the proper subset. So please try to understand. We just said that every set is a subset of itself. Every set is a subset of itself. Now, here when we denote subset using this. So this is the basic representation of subset. So in normal subset definition, equality condition is included. In normal subset definition, equality condition is included. If we are saying A is subset of B, then A may be equals to B as well. If A is subset of B, then A may be equal to B. Okay. But in a proper subset, what will happen? So in a proper subset, equality condition is not allowed. In a proper subset, you can eventually see that we have not mentioned this equality sign here with the subset symbol. We have not mentioned this equality sign, right? So what do I mean by proper subset? So for any, except the set A itself, for a set A, except the set A itself, all other subsets of set A will be called proper subset of A. Please. What? For any set A, all the subsets of set A, all the subsets of set A except all the subsets of set A except set A itself, except set A itself are called proper subsets of set A. Are called proper subsets of set A. Okay, let's look at this particular thing. Sometimes it may be confusing. Therefore, set A equals to 1, 2, 3. So, what are the proper subsets of A? Proper subsets of A are phi is a proper subset. 1, 1, 2. Obviously, 1, 2, 3 is not included. Not allowed. Okay. If I ask you, let A equals to phi. Let A equals to phi. Now my question is, what are the proper subsets of phi? What are the proper subsets of A? The only subset of an empty set will be empty set itself. The only subset of an empty set will be empty set itself, and that subset is equals to the given set. Therefore, no proper subset exists for an empty set. Clear? No proper subset exists for an empty. Clear? So these are the definitions related to subset, superset, proper subset, and then we'll talk about power set. So what do I mean by power set? For a finite set A, for a finite set A, power set of set A, power set of set A is denoted by, or power set of set A is a set. What is a power set of set A? Power set of set A is a set So power set is also a set, but what type of set? So power set of set A is a set of what? Set of all subsets. Set of all subsets of set A. Set of all subsets of set A. Sir, how do we denote this? So power set of set A is denoted by power set of A, or some textbooks also denoted using 2 raised power A. Some textbooks also denoted using 2 raised power A. Here, so power set of set A is denoted by this. Okay, anyway, not a problem. So let's try to understand this with the help of an example. Let's assume if I say A is whatever, or the ABC. So what will be power set of A? Power set of A. How do we denote this? Sir, power set of A. Sir, what is power set of A? So if you read the definition properly, you will get your answer. Sir, power set of A is a set. So power set of A will be a set. What will be a power set? The power set of a given set will be a set. But what are the elements of this set? So it is a power set of a set A is a set of all subsets of set A. So what will be the elements of power set of A? Elements of power set of A will be subsets of set A. Power set of set A will be subsets of set A. So what are the subsets of set A? So we already know. Subset of size 0 will be 5. Subset of size 1 will be A. Subsets of size 2 will be E. And subsets of size 3 will be ABC. So what is a power set? Power set of a given set is nothing but the set of all subsets of that set. Simple definition. Yeah. Okay, now basically if I look at the cardinality of power set of A, then what will it be? Cardinality of power set of A will be denoted using this. This will be equals to what? Sir, how many elements in the power set of A? Sir, how many elements in the power set of A? Cardinality of power set of A will be nothing but the number of elements in the set power set of A. Sir, how many elements? Sir, the number of elements in power set of A are exactly same as number of subsets of set A will be equals to number of subsets of set A. Yeah. So these are some things. Now, as I told you that I'll come back to this particular representation and we'll try to understand the number of subsets of a given set. Try to understand the number of subsets of a given set. With this number of subsets of a set A of cardinality n. So my question is, you just need to focus on this particular concept, and based on this we'll derive the number of subsets for any given set A. Sir, in this case what did we do? In this case, because the cardinality of set A is 3, cardinality of set is 3, then how many subsets of size 0? So number of subsets of size 0 will be exactly same as the number of ways in which we can choose 0 element out of 3 element. In how many ways we can choose 0 element out of 3 elements? So we can choose 0 element out of 3 element in 3C0 ways. Sir, how many subsets of size 1? This will be exactly same as the number of ways in which we can choose one element out of 3 elements. So in how many ways we can choose one element out of 3 elements? Sir, 3C1 will be 3. So the number of subsets of size 1 will be 3. Number of subsets 3C0 will be 1. Number of subsets of size 0 will be 1. Sir, in how many ways we can choose 2 elements to create a subset of size 2? Sir, we can choose 2 elements out of 3 elements in 3C2 ways, which is also equals to 3. Sir, in how many ways we can choose 3 elements out of 3 elements to create a subset of size 3? Sir, we can choose 3 elements out of 3 elements in 3C3 ways, that is 1. So what will be the total number of subsets? The total number of subsets will be nothing. Total number of subsets will be 3C0 plus 3C1 plus 3C2 plus C3. So I don't know whether I'll be able to do it. So total number of subsets of set A equals to 1, 3 are 3C0 plus 3C1 plus 3 plus 3. I don't know how many of you know NC0 plus NC1 plus NC2 up to NCN will be 2 raised power n. So 3C0 plus 3C1 plus 3C up to 3C3 will be 2 raised power 3, that will be equals to 8. If you don't know this, please have it in your notebook that NC0 plus NC1 plus NC2 plus NC up to NCN be 2 raised power, and it is obtained using binomial expansion. Yeah? This is the binomial expansion of 1 plus 1 raised power n. So this is how obtained 1 plus 1 raised power n. So it's actually nothing but 1 plus 1 raised power n, that is 2 raised power n. Then the expansion of this will be 1 raised 1 NC0 1 raised power n minus n 1 raised power n minus 1, etc. And you will eventually get this using binomial expansion. Please remember this, that this will be the solution. So similarly, if somebody asks me the number of subsets for a set of size n, number of subsets of us for a set of size n. So what do we know? So the cardinality of set A equals to n. So number of subsets of size 0. C0. Number of subsets of size 1. One, and so on. Number of subsets of size k. Obviously, you need to understand that this value k can never be greater than n. This value k can never be greater than n. So k has to be less than or equals to n. You cannot choose more than n elements out of n elements. So the number of subsets of size k will be nothing but nck, and you can have number of subsets of size n. So at most you can choose all n elements out of n elements. So number of subsets of size equals to n will be. So if I ask you the total number of subsets of set A, work. Leave it. Total number of subset equals to NC plus 1 plus NC plus this will be for, and that's one equation, but we'll understand some other things related to it. So total number of subsets will be this. Now if I ask you how many subsets of size k, if somebody asks me that how many subsets of set A such that the size of the subset is exactly k, number of subsets of size equals to k. If somebody asks me that, sir, what will be the number of subsets of size? What will be the number of subsets of size at most k? So, in at most k, the size of the subset may be 0, size of the subset may be 1, size of the subset may be 2, and up to it may be k. So, if you add this first k plus 1 terms from NC0, NC1 to NCk, then the summation of first and k plus 1 term will be nothing but the number of subsets of size at most k. Number of subsets of size at most k. Now, if I add this, a different color. So, if I add this NCk plus 1 up to NCk plus 2 up to NCk up to NCn, then you will get the number of subsets of size at least n. Least k, not at least. Number of subsets of size at least k. So I hope it is very much clear that yes, most of us will know this definition that for a set A of size n, the number of subsets of set A will be 2 raised power n. But most of the time in GATE exam, this will not be the direct formula that can be used within the question. They may frame the question so that they may frame the question which can be solved only if you know that how exactly this term 2 raised power n is derived. Makes sense? So there are other ways also to derive this particular formula, but this is the best representation. This is the best representation. So what do you mean by other way? So if I have A as a set which contains 1, 2, 3, 4, 5 up to n minus 1 and n elements, then the number of subsets will be what? Sir, the subset of set A will include or exclude the elements of set A. Subsets of set A will include or exclude the elements of set A. So for subset of set A, for subsets of set A, one can be chosen in two ways. I mean, you can leave A or you can choose A, and you can leave 2 or you can choose 2, you can leave 3 or you can choose 3, you can leave 4 or you can choose, come on, 2. There are two ways. Either you can leave 3 or you can choose 3. For 4 also, there are two ways. You can leave 4 or you can choose 4. For 5, you can leave 4 or you can choose 4. Similarly, for n minus 1, there are two ways. Either you can leave n minus 1 or you can choose n minus 1 for this element n. You can choose n minus, you can choose n or you can leave, and therefore the number of subsets will be 2 raised power n. Anyway, you do it. It's up to you. both of them are of equal importance. The only thing is, then don't simply mug this formula that for a set A of size n, the number of subsets will be 2 raised power n. If you are simply trying to mug up this formula, then it will not be of that much help. Please try to understand the derivation this way as well as using this approach. I hope both of them are clear to everyone. Okay. Now if we know the total number of subsets of set A, can you please provide the answer and tell me that how many proper subsets for set A? For, sir, we can obviously give the answer what, or if you want you can give this answer after the discussion of the number of subsets. Next note. Let mod A equals to n, then number of proper subsets, number of proper subsets of A will be 2 raised power n minus 1. Total minus A itself. Okay, next one is cardinality of power set. Next one is cardinality of power set. So I have already given you the intuition that, sir, what is our power set? Sir, what is our power set? Power set is nothing but a set of all the subsets of set A. Power set is nothing but the set of all subsets of set A. So if you have a power set, then the element of that power set will be nothing but the subsets of set A. So what will be the cardinality of power set of A? Cardinality of power set of A will be exactly same as number of subsets of set A. Cardinality of power set of A will be exactly same as number of subsets of set A. So, not. Let A is any finite set and A denotes the power set of set A. Then what is the cardinality of power set of A? Cardinality of power set of A will be nothing but the number of subsets of set A and therefore cardinality of power set of A. So what will be the number of subsets of set A? Number of subsets of set A will be nothing but 2 raised power cardinality of set A will be nothing but cardinality of set A. So, how many subsets? So, number of subsets will eventually depend on the cardinality of set A. That is, mod A equals to n, then cardinality of power set of A will be 2 plus power cardinality of set A. Generated, nothing much. Okay. Now, please remember one thing. So, there is a difference belongs to, if I try to explain one simple thing, that whether you understand the difference between belongs to and subset or not. Yeah. So let's assume let A equals to 1, 2, 3. Now my question is whether phi is a subset of A, true or false? Let's write it in the form of a question. Which of the following These are true. Phi belongs to set A. True or false? Is phi an element of this set A? No, sir. Phi is not the element of this set. Only three elements of the set A are 1, 2, and 3. So, this is false. We'll talk about them one by one. Now, tell me whether phi is a subset of set A. True or false? First, tell me true or false. So, this one is false. Phi does not. Phi is not an element of set A. Phi not an element. Belongs to means element. Okay. This one is true or false. Sir, phi, that is empty set, is a subset of every set. So this is true. Why? Empty set, that is phi, is a subset of every set. Okay. Third statement. 1 belongs to set A or not. Whether 1 is an element of this set or not. Yes, sir, 1 is an element of this set. 1 is an element of this. Next is whether 1 is a subset of set A or not. Come on, sir. For something to be a subset, first of all, it should be a set. For something to be a subset, it should be a set. But this one is not a set. It is just a simple element. It is just a simple element. So, sir, it is false. Okay. I'll explain the correct representation. The next option itself, you will come to know that. Tell me whether the set containing element 1 belongs to A or not. Sir, there is element 1. There is element 1 in set A. There is no element which is a set and containing element 1 which is present in set A. No, sir. A simple 1 is present in set A, but a set containing element 1 is not present in set A. Simple 1 is present in set A, but a set containing element 1 is not present in set A. Therefore, this is false. Clear? And the last one is, so this set containing element 1 is a subset of A or not? Yes, sir. When will this is one subset of set A and it is actually a subset of size 1. It is actually a subset of size 1 with respect to set A. So this is true. Makes sense? Clear, clear. Okay. Another thing which you must understand is that for any set A, I am writing for any set A, phi belongs to power set of A as well as phi belongs to power set of A as well as phi is a subset of power set of A. There are two reasons. Power set of A is a set. Power set of A is a set. Therefore, phi will always be a subset of every set. Phi will always be a subset of every set. Apart from that, power set of A is a set of all subsets of set A. So, phi is also a subset of set A. Therefore, phi will also belong to power set of A. Therefore, phi will also belong to power set of A. Another thing which people generally don't understand is, so this is a different thing and this is a different thing. These two are not equal. What is this? Set is a empty set. and it is a set containing n, set containing n empty. So please, there is a distinction. What is the cardinality of this? Sir, cardinality, it is a set which contains 0 element. Therefore, the cardinality of this empty set will be 0. But what will be the cardinality of a set containing an empty set? Sir, in this set, there is one element. And that element is an empty set. It's a different thing, but that's an element, right? So, cardinality of this will be, cardinality of this will be here. Please just try to understand the basic difference and you will be able to answer almost all the questions. What else? If I simply ask you one simple or leave it, so this is the question which will be asking. Why this will be one? I have in the end I have changed the orders of this to come to. This is number one. Fast. This is a question number one. For a set A, the power set of A is denoted by, so as I told you that it can be denoted using this or power set of A, both of them are same. If this is your set A, this is your set A, which of the following options is are true? Which of the following options is are true? First is phi belongs to power set of A. I just told you that phi will be power set of, phi will belong to power set of A as well as phi, that is empty set, will be a subset of power set of A. These two are equal. But tell me, third one is true or fourth one is true? Third one is true or fourth one is true? Do we have, this is a single element, sir. This is a single element. Do we have any such element in the power set of A? Do we have any such element in the power set of A? Sir, first of all, you need to think in terms of power set of A. Sir, what will be power set of A? Power set of A will be set of all the subsets of set A. So one of the subset will be phi. Another will be a set containing element phi, because this is one element. Another will be a set containing the second element, that is 6. Another will be a set containing this third element, that is 7. Yes, sir. Now choose 2. Sir, will be a set containing 2 out of these elements. One will be 5, another will be 6. What, sir? Another will be a set containing other 2 elements, that is 5, and one will be, another will be remaining 2, 6, and one will be a set containing the complete set, that is 5. So this is actually your power set of A. Now the question is, this is your power set of A. So this a set containing element 5 comma 6 belongs to this or not? Yes, sir, we can directly see it. Yes or no? So this is true. But tell me, fourth statement is true or false? You need to think with respect to the set given on the right hand side. It is not with respect to set A. If this is with respect to set A, then the statement, if at the place of 2 raised power A, if I simply write A, statement 3 will be wrong. Statement 3 will be wrong. But what is being asked is with respect to power set of set A, and with respect to power set of set A, this element, that is a set containing element 5 and another element as a set containing element 6, actually belongs to this power set of A. Now, please, do we have any subset of power set of A? Do we have any subset of power set of A which contains 2 elements, 5 and 6? No, sir. There is, do we have any element 5 here? If you create any other subset of power set of A, if you create any other subset of power set of A, first of all, there will be a set symbol, and within that one of this existing element or one or more than one element will be present. So even if you take this, then it will come in the form of a set containing element 5. This is not possible. This is not possible. Therefore, fourth statement is wrong. Fourth statement is wrong. Make sense? Clear? Okay, so this is another question. I will give you this question as homework. I will give you this question as homework. Try it by yourself. In tomorrow's session, first I'll discuss this question, then I'll explain the remaining topics. So please, we have introduced the concept of set, that it is nothing but an unordered collection of distinct elements. Then we know the cardinality of a set is nothing but the number of elements present in that set. Based on that cardinality, we can define the finite set and infinite set. If the number of elements within the set are finite, then it will be a finite set. If the set is not a finite set, then it will be called an infinite set. Apart from that, we have discussed different types of sets, empty set and singleton set, equal set, equivalent set, subset, proper subset, superset, universal set, all the different power set, all the different types of sets we have discussed, and we have also understood the concept of number of subsets and supersets. How many? Now, sir, superset will be defined with respect to universal set. So how? Let's assume. Let the universal set is 1, 2, 3, 4, 5 and A is equals to 1, 2. Find number of supersets of A. Sir, how many supersets will be there for set A? Sir, the supersets of set A will be derived with respect to universal set. So we know that the universal set is nothing but 1, 2, 3, 4, 5. Now, for the resulting set to be a superset, the very first requirement is that the element 1 and 2 must be present. So there is only one way to choose element 1. There is only one way to choose element 2, that this should be present. But for remaining elements, there are two choices. They may or may not be present. For the remaining elements, there are two choices. For each, they may or may not be present. Therefore, 2 raised power 3, that is 8. So number of supersets will be with respect to universal set. So that's why I did not define that in the form of formula, because it will become clumsy that what is the size of the universal set out of that universal set. First of all, you need to know the size. So if I try to generalize this, it will not be a good idea. But if I try to generalize this, then what will be the number of supersets? If mod A equals to n, then number of supersets of A will be equals to, out of 2, the total cardinality of the universal set. Out of those total, n has to be fixed and remaining will have two choices. N has to be fixed and remaining out of universal set will have two choices. So you can actually apply it here. So the cardinality of set U is 5. Out of 5, 2 are fixed, remaining 3 can be chosen 2 in different ways. So 5 minus 2 will be 3. So 2 raised power 3 if you want to generalize it, but don't try to generalize anything. Don't try to mug all the formulas. Otherwise, it will be very confusing. Yeah. Now, we have also understood the concept of power set. Sir, when exactly an element belongs to a set, when exactly something will be a subset of a given set, please try to focus on that particular aspect carefully, because most of the time, while trying to save some time, you may commit some silly mistake and you may provide the wrong answer in the final exam. So please make sure that you understand this concept when belongs to and subset properly. And we also know the cardinality of power set will be exactly same as the number of subsets of set A. That will be all for this particular session. Tomorrow we'll discuss about relations. So in the today's session, I have introduced the concept of sets. Whatever is required from the today's session, I'll revise it in the tomorrow session, and then we'll start with the concept of relation in the tomorrow session. So that will be all for this particular session. Thank you very much for joining. Keep attending the session, and I'm damn sure that if you watch all these sessions, then definitely you will be able to score enough number of marks from this topic of sets and relations, set theory and algebra, because I'm going to cover complete set theory and algebra. Okay, so that will be all. Thank you very much. See you tomorrow at the same time, that is at 4 p.m. Till then, take care, keep learning. Have a wonderful day.